Well, welcome to lesson 23. You had the same power up as we did on Monday. Hopefully the quiz is done and you rock that out. The answers read like this. Distance is circumference, the center is the center, the distance across is the diameter, center to edge is radius. The bullseye is called concentric circles. Side to side is called a chord. Part of the circumference is an arc. Arc and the two radii form a sector. Half of a circle is a semicircle. The angle in the center is a central angle. When it's on the edge, it's an inscribed angle, and then we put a polygon in there. It's an inscribed polygon. Your mental math section reads like this. I added and subtracted 2 pennies from it. I got $4.63. Dividing by 100 slides it to the left twice, so 25 cents. I subtracted, it's backwards, so I know my answer is negative 51. Multiplied 496. Half plus a half is a whole, so 1 plus 1 plus 2 is 4. Half of 76 is divided by 2, 38. What fraction of a minute is a second? I know there's 60 seconds in a minute, so it's 1 over 60. Multiply 64 minus 1, 63, divide by 9, 7 times 4, 28, minus 1, 27, divide by 3, 9, times 2, 18, plus 2, 20, divide by 4 is 5. Problem solving says altogether how many dots on the 6 number cubes are not visible in this illustration. Now you could try to picture all those different number cubes and what's on there. Here's what I did. I know a number cube has the numbers 1, 2, 3, 4, 5, and 6 on there. So I add those together. I know they're always opposites. They always add up to 7. So a 7, and a 7. So that's a total of 21 total dots on a number cube. If I take that 21 and say, what's the total on 6 of those? I'd be taking 21 times 6 and getting 6 and 12. We have a total of 126. Second step I did is I took all the numbers that I see and I'm going to add them together. 6 plus 2 is 8. 4 plus 2 is 6. 6 plus 3 is 9. 4 plus 2 is 6. 1 plus 4 is 5. And 3, 2, 1 is a 6. So I added each dice individually. Now I got to add all those together. 14, 23, 20, 14, 23, 29, 34, 40. Okay? Then I take my 126 and I subtract the 40 from the dots I can see, and I get 86 dots that I can't see. So solved it all with math. Instead of trying to visualize it, you could have certainly visualized it, especially if you have a dice. You could think what's there, what I saw, and then I would have added what I don't see. So I could have done 1, 3, 4, and 5 to this one because I don't see those numbers. I tried to reduce the amount of math as much as I could. All right, let's go back to yesterday. Quick review. We were working at finding parts of a whole, multiplying that by the group. So choice 1 was draw a diagram, chop it into parts, and answer the question. Choice 2 was take your number. Let's say there's 3/5 of the 30 students. Take my 30, divide by my denominator. 30 divided by 5 is 6, times it by my numerator and get it. Or your other choice is take that whole number, put it over 1. So 30 over 1 times 3/5 or whatever your fraction is. Then you can do cancel and multiplication. We'll learn canceling coming up later this week, which will make the official lesson there, and then hopefully you'll see that and practice that a lot. Today, we are doing nothing that has to do with equal groups, guys. We're doing subtraction with mixed numbers, and you have to regroup them today. So it's not just straight subtraction. You have to do another step. Let's get started by our lesson. It says this. In this lesson, we will practice subtracting mixed numbers that require regrouping. Regrouping that involves fraction differs from regrouping with whole numbers. When regrouping with whole numbers, we know that each unit equals 10 of the next smaller unit. However, when regrouping from a whole number to a fraction, we need to focus on the denominator of the fraction to determine how to regroup. We will use illustrations to help explain the process. Okay, so it says there are 3 1/5 pies on the shelf. If a baker takes away 1 2/5 pies, how many pies are on the shelf? So they just gave me a word problem that says you need to do some subtraction. I have 3 1/5, I'm minusing 1 2/5. Now what they're saying in their lesson of when we used to do subtraction with whole numbers is easy. Cross out the 3, carry a 1, done. That's not how it works with fractions. So what I'm doing is I'm crossing out the 3, making it a 2. I'm carrying over a whole 1, but I'm working with 5s. So a whole 1 is 5/5, not 10, which what we're used to. Then I have to take that 5/5, I have to add it to the 1/5 that's already there. So 5 plus 1 is 6/5. Now I can do the subtraction. 6 minus 2 is 4. The 5 stay the same. My whole number is 2 minus 1 is 1. So what do I have left over? I have 1 and 4/5 pies left over. Okay? The caution I would give you guys is you have to do what's best in subtraction. You can see how I crossed this out, brought the 5, added it, and then I subtracted at this angle. Sometimes it's easier to rewrite it and move everything over so that your subtraction is straight up and down. Some of you say, I don't want to have to do that extra step of writing, so make sure you're just doing it at an angle, but don't get confused with that as we have to do that kind of math today. Okay, as you turn your page in your book, guys, they give you we're going to explain this to you through illustrations and drawing all kinds of pretty pictures. I personally don't like pictures because what do you do when they say there are 15 and 2/5 pies and you took 8 and 3/5 pies away? I'm not about to draw 15 pies. So I want to know the math steps to it because the math doesn't matter the size of the numbers, I can do that. So I'm not going to spend time drawing pictures. If this is a challenge for you, you'll notice that some of them start out kind of small, so pictures would work until you get the hang of it. Example 2 says 3 and 5/8 minus 1 and 7/8. So once again, I'm right here, it's a subtraction problem. Cross out the 3, make it a 2. This time I'm bringing over 8/8. So guys, whatever your denominator is, that's what your numerator is. Add them together. 5 plus 8 is 13. The 8 stay the same. I'll rewrite it for you. 2 and 13/8 minus 1 and 7/8. Subtract. 13 minus 7 is 6. 8 stays the same. 2 minus 1 is 1. Same as number 1, except now for number 2, how they make it one step more difficult. Now I have to reduce. So we already know how to do that, so be ready for that. It reduces to 1 and 3/4 by dividing by 2 over 2. So they add that next step to us as we work through the problems. Example 3, I'm now working with percentages. I have 83 and 1/3% minus 41 and 2/3%. Now we're getting bigger numbers. Cross out the 3, make it a 2, adding, this time 3 over 3. 1 plus 3 is 4. 3 stay the same. I'm going to bring my 82 across. Bring my 41 and 2/3 across, and now I have a subtraction problem I can do. 4 minus 2 is 2. 3 stay the same. 2 minus 1 is 1. 8 minus 4 is 4. Don't forget your percent. 41 and 2/3%. So now we got a little bit bigger numbers that we worked with that one. Example 4. This time it's a whole number, there's no fraction. So I'm going, I don't know what to, just look down to the next fraction. Whatever fraction's here is what fraction I'm going to work with there. Cross out the 6, make it a 5. I'm working with 4s, so I have 4/4. That's the whole one that we bring across. 4 minus 3 is 1, 4 stay the same. 5 minus 1 is 4, and I have 4 and 1/4. Okay? I actually think that's easier than some of these because I didn't have to do the step of addition. The challenge with it is to making sure I know what I'm working with, and you just go down to the lower fraction. And then last but not least, this time they gave you 100% minus 16 and 2/3%. Okay, so these will be problems in the future that they'll say, hey, take it away from a whole, and you need to know whole is 100%. Same thing though, guys, I cross out the 100, I make it a 99. I'm working with thirds this time, so I have 3/3. 3 minus 2 is 1, thirds stay the same. 9 minus 6 is 3, 9 minus 1 is 8, and I have 83 and 1/3%. 16 and 2/3, guys, is actually 1/6 as a fraction. This is 5/6 as a fraction. So in the future, they'll give you what is 1/6 as a percent? What is 5/6 as a percent? And this is literally the problem I have to do to try to solve those things. Okay, so today, guys, we're subtracting with this regrouping. Make sure you cross out and you work with whatever it is we're working with there. As you do that subtraction, add it to it, and then make sure you line it up or you're good enough to be able to subtract at that angle to be able to get the problem with it. They give you a number of practice problems on the next page. If you'd like to do some of those, I'll see you for the problem solving. Sixth grade, here we go with lesson 23. We start with number 3. It says, write a formula for area of a rectangle. Area of a rectangle is length times width, so with abbreviations, it's just L and W. Then it says a professional basketball court is 50 feet wide and 94 feet long. What's the area of the basketball court? So now I just stick the numbers in. I'm going to do 94 times 50. 5 times 4 is 20. Carry the 2. 45, 46, 47. So this is 4,700, and we're working with area, so it's square feet. Number 4, a 16-pound turkey costs $14.24. What's the price per pound? So I have a total pound, and I need to divide it by the 16 total pounds that the turkey weighed. So I take 16 into 142. That goes in there 8 times. 8 times 6 is 48. Carry the 4. 8 times 1 is 8 plus 4 is 12. I do the subtraction. Cross out the 4, make it a 3. Subtract, get a 4. Subtract, get a 1. Bring down a 4 here. I'm going to look at this number when I multiplied by 8. So I'm going to bump this one up to 9. Gives me a 4. Carries a 5, plus 5 is 14, so I'm done. My decimal point went straight up. I put a 0 here to make it look like money properly, so it costs 89 cents per pound. Number 5, from yesterday's lesson, 3/8 of the 56 restaurants in town were closed on Monday. How many restaurants in town were closed on Monday? So I'm going to divide by my denominator, 8. Goes 7, multiply by my numerator, gives me 21. 21 restaurants were closed. Then the next question says, how many were open? So I start with my total, I subtract the ones that are closed, and I get 35 restaurants were open. Okay? Go on, write the whole word out. A, B. Number 7. After contact was made, the cephalroid sailed 4,140 inches. How many yards did the cephalroid sail after contact was made? So step 1, I have to write 4,140 inches. Now I'm changing that to yards, guys, and I need to know that there are 36 inches in a yard. And so I'm going to divide by 36. Goes in there once. Is 36, subtract is a 5, bring down the 4, that's a 1, gives me a 36, subtract gives me an 8, bring down a 0, divide by 5 is 180, so it went 115 yards. Number 9, describe how to find the reciprocal of a mixed number. Okay, this is a 2-step process, guys. Step 1, switch the mixed number to improper, comma, then flip numerator and denominator. So it would look like this if I was going to demonstrate this for you. I have 3 3/4, let's say. If you want to write the reciprocal of this, guys, it's not 3 4/3. That's wrong. You have to make this a mixed number. 12, 13, 14, 15 fourths. Then that switches, and you have 4 15ths. This is the reciprocal of this, okay? Don't just flip the fraction over. So, wow, I spelled switch wrong there. Sorry, I forgot the AEC in there. Switch mixed number to improper, then flip the numerator and denominator. Sorry for the sloppy handwriting. It's not that easy to write with this penny thing here. Okay, number 12. Complete each equivalent fraction. So I had 3/4 times something gave me a 40 times 10 over 10 would give me 30 over 40. Next one, I had 2/5 times I don't know gave me something over 40. That would be multiplying by 8, which would give me a 16. The last one is going the other direction, which is I don't know over 8 equals 15 over 40. This is reducing, guys. You're dividing by 5 over 5. So divide by 5 and you get a 3. Number 13, the prime factorization of 100 is 2255. We can write the prime factorization of 100 using exponents, 2 squared times 5 squared. Write the prime factorization of 400 using exponents. Okay, so the first thing I need to do is break down 400. This is going to be 40 and 10. This is going to be 2 and 20. This is 2 and 5. This is 2 and 10. This is 2 and 5. So I have 1, 2, 3, 4. So I have 2 to the 4th power, 1, 2, times 5 squared. So that's your answer for A. B says, now write the prime factorization of the square root of 400 using exponents. Remember, guys, we divide the numbers in half. So I take my exponent and I just cut it in half. 4 divided by 2 is 2. 2 divided by 2 is 1. Now you can write the 1 or you don't have to write the 1. But this is the letter B. I don't have to redo a factor tree for that, guys. I just cut my exponents in half. Now if the exponents are ever odd and you're saying I can't cut an odd number in half, it's because it doesn't have a square root number, guys, okay? So it won't have an even square where it won't be a perfect square if it's not two even numbers. 15. Find fractions equivalent to 4/3 and 2/3 with a denominator of 12, then subtract them. So I got 3/4 minus 2/3. I have to get them to 12s. I have to multiply by 3 over here and by 4 down here. 3 times 3 is 9. 2 times 4 is 8. Subtract 9 minus 8 is 1. 12 stay the same, and I have 1/12. Flipping my answer key over, number 18. Missing something in addition. If I'm missing something in addition, I switch to subtraction. So I have 6 and 3/4 minus 1 and 1/4. 3 minus 1 is 2, 4 stay the same. 6 minus 1 is 5. Then I divide by 2 over 2 gives me 5 and 1/2 when I reduce my fraction. So you have a fraction of 5 and 1/2. Number 19, missing the first in subtraction. When I'm missing the first in subtraction, I add. So I have 4 and 1/8 plus 1 and 5/8. Add 1 plus 5 is 6. 8 stays the same. 4 plus 1 is 5. Once again, I have to reduce by dividing by 2 over 2. 6 divided by 2 is 3. 8 divided by 2 is 4. 5 stays with it. I have 5 and 3/4. Number 21, from today's lesson, I have 83 and 1/3, and I'm subtracting 66 and 2/3 from it. Cross it out, make it a 2, bring it over 3/3, add 3/3 to 1/3, and you get 4/3. 4 minus 2 is 2, the 3 stay the same. Have to borrow again. 12 minus 6 is 6, 7 minus 6 is 1. It's a percent. I have 16 and 2/3%. As fractions, that's 5/6 minus 2/3 equals 1/6. Just so you recognize those things. Jumping down all the way to 26, turning the page in your book. Mary wants to apply a strip of wallpaper along the walls of the dining room just below the ceiling. If the room is 12 by 14 rectangle, then a strip of wallpaper needs to be at least how long? So I have a rectangular room that is 14 by 12, and she wants to put wallpaper along the edge of all of it. So I do 14 plus 12 is 6. 1 plus 1 is 2, and then I take that times 2 because there's 2 14s and there's 2 12s. So 26 times 2 is 52. We're talking feet there, 52 feet. Number 29, A sequence for perfect squares, for perfect cubes is k equals n to the third. May be written as in A or as in B. Find the next two terms of both sequences. So A, I have 1 cubed, 2 cubed, 3 cubed. What's the next one? 4 cubed. After that would be 5 cubed. B is actually doing the work. 1 times 1 times 1 is 1. 2 times 2 times 2 is 8. 3 times 3 times 3 is 27. I have to do 4 times 4 is 16. Times 4 again is 4. Carry the 2, 6. So B, the next one is 64. Then I have to do 5 times 5 is 25. Times another 5 is 125. So those are the next two. This one, the sequence, this one, the answers. And 30. The figure shows a circle with a center point at M. Which chord is a diameter? Remember, diameters go through the middle and go from side to side. So if I have this drawing here, guys, you are going from side to side. This is A, this is B. So my chord would be AB. It's a segment. B says, which central angle appears to be obtuse? So obtuse is coming out of the edge. So it's going from B, hitting the middle, which is M, and it's going down over here to C. So this is angle sign BMC. Name an inscribed angle that appears to be right. So now I'm supposed to find an inscribed angle. That's choice 1, this is choice 2, this is choice 3. And by looking at choice A looks acute, choice B looks acute, choice C looks like it's right. So if I was going to name that correctly, I would go from A to C to B. Don't forget your angle symbol. Now guys, notice they use the word appears because they didn't put the box in there. They're saying it's okay for you to go with looks. They wanted you to prove it to you. They had to put a box in there, but they did not.